Hello, and welcome back. Happy New Year. Welcome back to another Spindle TV exclusive class, learning at its best. I hope you all had an amazing holiday break, if you will, or for yourselves. I don't know if it was a break for you. It was a little bit of a break for me. I did a lot of work, got a lot of stuff done, and getting ready for the new year. And all in all, it was a very productive week and a half, 2 weeks, what have you. I've got some announcements to make. I've got some information to provide, and I have some things to teach you. Tonight, we're going to talk about the principles of speeds and feeds when it comes to router bits. And hopefully, the goal is eventually one day, if you practice at it and follow through with what you're learning or what you're observing visually and audibly and things like that, that eventually one day your tool database and Vectric will be built in a way that when you set up a job and you choose your material and you choose your bits, it's going to be the right, the right type of tool and the right type of cut for clean, finishes and things like that. And to achieve that, it really starts with some very simple principles, and that's what we're going to cover tonight. And we're going to, go through it. So first of all, again, Happy New Year to everybody and all. Over the break, you may have received an email. Hopefully you received an email from me asking, or no, not just an email. It might have been announcements too, email, what have you, but asking for you to email me your email address. And the reason for that is that there is a new hub, if you will, a new website that will be for you, Spindle TV exclusive members, and only you. And there is an area of the website that is public, that people can see in the public, so people can see what Spindle TV exclusive is about, and they can see if it's something that they want to be a part of, and help the community grow. Within this hub or within this website, there is an area, a members area, that will require you to log in. And the purpose for asking for your emails is the website gateway, the lock, the turnstile, whatever you want to call it, has each and every one of your emails, that the ones that did respond and provide it to me, for all the gold members and all the silver members. And when you log into the member site, it'll ask for your email address, or it'll ask for you to enter your email, and it will send you a code. As soon as you put in your email, it sends you a code. You type in that authorization code, and it authorizes you into your area. Silver members can access the silver member area. Gold members can access both the silver member and the gold member area. They have access to it all. If you did not respond, I got a couple of emails tonight, people who might have just saw the message or what have you. But if you did not respond to the email asking for your email address, what I need is, I'm going to post it in the chat here. What I need is, or I'll post it online here, right here, my website, or not my website, my email address, laney.shaughnessy@spindletv.com. Need you to email me, subject line, my email, right? My email, and email me your email address so that I can enter you into this gateway, so that when you do enter your email address, it allows you in. If your email is not in the gateway, then it will not allow you into the member area at all. So if you have not emailed me your email address, please do. And I'll say this, of the, let me see here. 1 second. Of the exclusive members, of which there's 45 of you, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 emails. So there's more than half of you that have not provided me with your email yet. So on the screen is my email address, subject line, my email. If you have not responded to that email, send me an email with your email. I said email so many times. Send me an email with your email address in it, your name and your email address, so I can add you to the list. Now, the this member area was supposed to launch now, right? However, there's one little thing that I've got to get past before I can launch it, and it wasn't my fault. Wix.com did it to me. I was in the process of transferring the Spindle TV exclusive domain to get it set up and everything, so I could set up the turnstile, the locking gate, and everything. I can show you what the site looks like and all, but when a domain transfers, after the transfer is complete, it's locked by a company called ICANN. ICANN is a government agency that controls all numbers and things like that, just like your social security number kind of thing. But internationally and nationally and all, and there's a 60-day lock. Once the transfer is complete, you cannot transfer it to another host or another, provider or registrar or anything for 60 days. It's a safety thing. Well, when I initiated the transfer, Wix didn't complete the transfer, but they triggered the lock with ICANN. ICANN is a government agency. I talked to them. They sent me some nice, wonderful, long emails telling me how they unfortunately can't help me turn off the lock for 60 days. So February, unfortunately, I got to wait till February 26th for all the safeties and things to lock. So, but I can give you a little bit of a show and tell and everything. And it's just a bit disappointing that I can't get it completely fully launched right now for you all to be able to access your areas and everything. And there's not a whole lot in them right now. I'm building up all the curriculum. There's downloads in there. There's the past videos all organized. There is quick sheet guides and things, all of that stuff, and nice stuff to download. And then there's going to also be project files, practical project files for learning, how to do this, how to do that, and kind of a breakdown, PDF breakdown, and then the actual project files themselves. It's a really nice. I feel like I got hair all over me. It's a really nice setup, and unfortunately, it's not fully there yet. It's not fully releasable because of the screw up on Wix's part. But what I can show you is the website. Let's see here. And I don't mind right now that y'all have the URL and can get in and all, because there's nothing really, none of the separation and all, none of that's done and all that yet. Anyway, so you can at least get to see it and kind of see what it looks like. So I'm going to share my screen. Share the screen. Okay. And let me get the email address. Everybody should have the email address by now. And everything. So within the Spindle TV exclusive website, The main area, when someone goes to exclusive.spindletv.com, they come into the main area here where it tells them, about what Spindle TV exclusive is. It's a private hub for CNC and Vectric training, live classes, member only downloads, join on YouTube, and then you can use the gold or silver or gold dashboard to access anything, within. There are, of course, the membership options that you're very much aware of, the silver and gold, and it tells them how it works. Eventually, there's going to be a platinum level as well, too, for the hardcore learners. But the different perks and things that you're very much aware of, silver members, it is beginner or expert, level. Doesn't matter if you're just, you've been carving and running CNCs for years, or if you're just starting, yesterday. There is learning sheets and things like that are just, that are easy to kind of get the fundamentals down and even beyond. The silver access, you get access to all the videos. Of course, you guys all have access to the videos and everything. The public doesn't have access to the videos that y'all learn these classes and all. And then the gold members, again, they get the silver level, plus they get their additional perks as well too. And so the website, Learning Fundamentals, weekly sessions, that we're going to talk about in just a second. That's going to change up for a moment. Downloads, there's going to be files and everything. There's going to be all kinds of stuff. And so unfortunately, the member area isn't fully ready and all that stuff because of the Wix glitch. And that happened New Year's Eve. I was hoping to be able to launch, to be ready by today, but I was hoping to be able to launch by the 2nd of January and be fully packed to the max with all the cool stuff and everything. But Wix screwed it up. So, and without the domain transfer and all, it can't lock, they can't separate the areas and all that stuff. So the benefits really just kind of go out the window at that point. And stuff like that, why someone's a gold member, why someone's a silver member. You get benefits and you get perks for each. And right now, without a lock or a separation, it doesn't make there's no advantage to, being one or the other kind of thing on the website. And so I'm really excited. I did a lot of work on the website and getting it, ready to go. You're only seeing a portion of it. You're not actually seeing the member area and everything. But you're just seeing kind of the front end, what the public sees and stuff. And I'm super excited about what's to come. The one cool thing is in the member area, you'll see the links to the classes, right? Not last minute, like, 10 minutes before the class starts, a link pops up in, Facebook or here. They're going to be, the schedule is going to be 16, I'm hoping, knock on wood, will be scheduled 16 weeks out. The classes will be. That way you kind of have an idea of what's coming up or what's happening and all that stuff. You'll have the links to those those scheduled classes and all. They'll already be pre-scheduled with the links and everything. So I'm really super excited. All right, one more time, I'm going to show the email on the screen. Right here at the bottom left corner. Let me get JR and the guys in here too. Give me a second, JR and guys. I'll get you on screen. Bottom left corner, Laney.Shaughnessy@spindletv.com, Belize Breeze, and everything. So email me your email address so I can get you in the list if you're, in there and all. So bottom left corner, laney.shaughnessy@spindletv.com and everything. So I'm super excited about that. And that's, I'm really, really, really pumped about that and everything. All right. So now let me bring the boys on board. We got JR and Keith. And Keith, are you also KK? K Kessler? KK? No, that's Kevin. Kevin. Sorry, I got two Keith Kessler. I got two KKs, two Keith Kesslers.
Yeah, I'm logged on.
Kevin, Keith, and all.
As long as you don't have KKK.
Let me get y'all up here. How are y'all doing?
Good.
Doing good.
All right, wonderful. And for those of you in the chat that are new to Spindle TV exclusive Gold members, get a special link to allow them to come on screen and join me live on screen, just like you see here with JR in the bottom. It would be camera bottom left. Are you guys? I think y'all see it the same way I see it on the screen. Bottom left corner is JR. Kevin is the bottom right corner, and Keith is up in the top right corner. And of course, I'm over here. How you doing? And then, Gold members can access the come on live with me and everything to just hang out and talk and collaborate and all that wonderful stuff. So that's one of the benefits of the Gold members. So even though I can't launch it fully and all, what do you guys think about the prospect of this coming out here very soon as I can get the lock worked out and everything? And what do you think about that so far?
I think it's going to be great when it's working.
It's going to be amazing. I think it is. There's a lot of cool stuff that's going to be happening on the back end. Let me see here really quickly.
Assuming it's going to replace all the rest of the sites and connections and so forth, Laney?
What sites and connections?
Like Spindle TV. I thought you had a Spindle TV.
Yeah, no, there was never a spindletv.com. There was never a spindletv.com. There was a buildittv.com, but never a spindletv.com. So exclusive.spindletv.com is just a website just for exclusive members only. The other Spindle TV website, which is training.spindletv. Training.spindletv is a website that is for the public, but it's built around and mastering for digital woodcarver customers and mastering their workflow with their digital woodcarver machines. So that's training.spindletv.com. And then give me 1 second here. I'm trying to find one moment. Hang tight, ladies and gentlemen. One moment. One second. I want to show. So I'm in the process of working on the 60-day lock transfer, right? And so they gave me a list of things that I've got to do and everything. The email, came across and, why their policy is the way it is and blah, 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 and all that stuff and everything. So, and I respect the policy. It's a great safety thing for, website companies and all, but in my case, the criteria wasn't met. The criteria is if the name or the owner or contact information of a website changes, or if a transfer occurs, a lock is initiated for 60 days, and neither one of those things happened. There was no change in the contact information. There was no transfer. The lock got initiated. And so Spindle TV is exclusive as handcuff. The actual spindletv.com domain is locked until February. So I've got to jump through a few hoops to get it. But in the meantime, I've been able to at least launch the main part, not the security part. But again, training.spindletv.com is one website that has nothing to do with Spindle TV exclusive, guys. This is for digital woodcarver customers and also the public that want one-on-one private sessions. There are the private sessions are pay as you go, monthly sessions or annual sessions. Let me make this. Sorry, y'all can't see nothing here. So on spindletv.com. Oh, come on. Guys. Give me a second, guys. I'm going to get y'all balanced out here. On Spindle TV, training.spindletv.com. This is a Master Vectric and CNC workflow hub that is just for digital woodcarver customers, also the public that want one-on-one sessions and everything. So there is, like I said, different training options and different learning abilities and all that. Then through Digital Woodcarver, there is what's called the DWC Skills Lab, which is a bi-weekly class, group training class that is machine specific to machine learning and everything for Digital Woodcarver CNC machines. There's Spindle TV exclusive. Exclusive.spindletv.com is going to be y'all's website, which is here. And then there, the Build It TV websites, which right now is price.buildittv.com is focused on the pricing calculator. I don't know if we talked about that. I think we had a class on it and everything. So the product pricing calculator is price.buildittv.com, and everything about it and the guides and learning on how to set prices for your machines and stuff like that. That's open to the public and all. And then, of course, there is the manual.omnicontrol.systems, which is another website. All of these websites I own and manage, but this is the new user manual for digital woodcarver CNC machines and the new Omni Control program that it's basically an owner's manual for the digital woodcarver CNC machines and things that covers, milling, laser, rotary, tool chains, things like that.
That's
so
new.
Lots of stuff happened over the last 2 weeks. Lots of things were written, lots of websites were launched, and lots of information going out. And the only thing that locked me up was the attempt to transfer. I had to transfer the website to the exclusive website in order to get the lock, the membership area and all that stuff. And then, of course, I don't know if Wix just didn't like it or didn't like me leaving them or whatever. But anyway, they triggered the lock and they didn't do anything. They didn't finish their part. So that's where we're at as far as the announcements and stuff, as far as the new website and everything. I'm hoping that when the actual full website launches, that y'all will think, holy wow, I'm really loving this now, kind of thing. Now we still have, for those of you, this is for everybody now. This is for everybody. If you have Facebook, and you have a Facebook account and you're not in the Spindle TV exclusive members group on Facebook, got to get in there, because I'm going to start pumping that Facebook group with some information too. And everything's going to link back to the website. But anyway, if you got a Facebook account, you're a Spindle TV exclusive member, silver or gold and all, you got to get into the private exclusive club on Facebook, because down in the Facebook group, you have access to me 24 hours a day. Whenever you post a post, I can reply to a post. It's a great way to collaborate or ask questions or things like that and everything. And how you get in the group, it's not open to the public. You can't search it on Facebook. It's hidden from the world. It's by invite only. So in the chat, I'm going to give you a link to my profile on Facebook, which is facebook.com/Laney.Shaughnessy. And let me verify that is true. Let me verify that is true. I got so many tabs open. Let me verify that is true. Stand by 1 second. There's only one tab that gets into the Facebook account. Hold on. Yes, Laney.Shauna. Cool. Okay, I got it. That was correct. So here we go. This is my personal Facebook profile. In order to get an invite into the Spindle TV exclusive group, we got to be friends. So you got to open up my profile and you got to send me a friend request. And once we're friends, then Facebook will allow me to send you an invite into the group. On the link that's in the chat right now, that Facebook link, that's my profile. If you and I aren't friends or linked up or whatever, just click add as a friend. It'll ask me to add as a friend. Once I confirm, or once I accept the friend request, then I can send you a personal invite to the group, and then you're in. You got full access to the group and everything. So that group right now there's only about, there's 45 members and there's only about 21 of you in the group, 21 to 25 or something like that in the group. There's half missing. I'm expecting, if all goes right with 2026, on Spindle TV, just Spindle TV, the website or the YouTube channel, right? Spindle TV. I have been fortunate enough on Spindle TV that it's grown. It's not my main channel, my main woodworking channel, but it's my CAD CAM channel. It's grown. There's 11,500 of public members that are watching. It's only 49 exclusive members of that 11,000. And they don't get to anyone outside of that for you Fast 49, you favorite 49. They don't get to see the classes or the lessons or the website access or none of that stuff. They don't get that unless they become an exclusive member. And what I'm hoping is the exclusive member group will grow, which will grow the different types of projects and interactions and the collaborations and all kinds of fun, cool stuff for everybody. And in the Facebook group, I'm hoping that you all that are exclusive members that have that common goal of being exclusive members, that you'll start collaborating with each other and talking to each other and asking questions and getting answers and supporting one another. Many of you don't know, many of you aren't Digital Woodcarver customers and stuff like that, but Digital Woodcarver, I built, we have a group called the Digital Woodcarver Owners Group. Fabulous, fabulous group. You go in there and you ask a question and everybody jumps right in and they're there to answer for you. There's nobody knocking anyone down. They don't care what skill level you are. It's just a wonderful, homogeneous, means it goes together, group. And I know there's some guys out there going, what? What'd he say? Anyway, but it's just an amazing group. Everybody's there to help everybody and everything. And that's what I want Spindle TV exclusive group to be. I want it to be bad to the bone, where people are dying to get in there, and just because it's so, there's a wealth of knowledge, from all of you and everything and all that stuff. Okay. So that's that. So now here's the kickoff of it all. Okay. Here's the kickoff of it all. The live classes, these live classes and everything, they are not going to be every week, every Thursday. They are going to be every other Thursday, twice a month, the live classes. Between the live classes, when the live classes are, there is going to be videos put out just for exclusive members on project videos. And I'm hoping that I can really do some really nice project videos that are beautifully edited, Wonderful learning. There's a PDF document with cut lists and things like that, or whatever that go with it. And those are going to be released kind of on a bi-weekly basis, so it fills up the month. I need to be able to have that shop time to be able to make those projects, to be able to provide y'all with this content that I want to give you. It's going to be, you're not losing anything by the bi-weekly classes. You're going to be gaining some very, very nice project files, downloads, learning material, PDFs, and everything that's going to help you with your growth, your CNC journey, and things like that. I'm really going to blow this up, and so that you think your silver membership or your gold membership is worth absolutely every penny that that it is, in everything. The last year, it was okay. We have our live classes every week. Some of the topics were great. Some of them were good. Some of them were all right, and all that stuff. But it really wasn't like, oh man, I'm really happy to be a part of this, this community, man. I'm learning the shit out of my machine, and I'm doing this and I'm doing that, and I'm really learning. I mean, I'm kicking butt here and all that stuff. That's what I want you to feel like, right? That's what my goal is to give that to you. And so I need to be able to have that shop time, live FaceTime, and all that stuff. Now, in the middle of all that, scheduled, it will be scheduled on the schedule. You'll have access to the schedules and all that stuff. But there's going to be what's called an office hour Q&A live event. The office hour Q&A live event is basically kind of like a 9 to 5. It's going to be like, when I'm in the office and all, it's going to be a live event to where everybody can come in, or anybody, exclusive members can come in and just ask questions, project questions, just a Q&A, and everything. Now, we're not going to be getting into, specific troubleshooting or projects and everything. That's what the one-on-one, sessions are for and all. This is a group learning and all. But the Q&A, absolutely, you can ask any question that you want, and we're going to go over and answer it the best I can, because your question is going to help other people that are watching learn too, right? So everybody that asks questions, that does participate, that uses it for what it's going to be, to learn or to get past obstacles or hurdles and all, the answer that I give, or that we all give or collaborate, whatever, the answer that's given is not just going to benefit you for asking the question. Yes, it's going to benefit you, but it's going to benefit everybody that's watching. And so it's called Office Hours Q&A. So throughout the month, along with the live classes, the biweekly live classes, the biweekly project files that go out and everything, and project classes that go out, there's going to be these office hour Q&As, and everybody will know exactly when they are, so they're not going to miss anything, because there's going to be a full calendar that you'll have access to, that you'll be able to log in and see exactly what's going to happen when. And it is going to be exactly what happens when. It's going to all be on the calendar, so you can start kind of like planning, instead of these last minutes. Is he going to have a class? Is he not going to have a class? I wonder what he's doing, because I'd like to be able to go have dinner, but I don't know. I'd like to see what he's teaching and all that. You're going to know way ahead of time. So it's going to be so much better. It's going to be better for you, better for me, better for just everything. So I hope the effort and the work that I have put in, and when you see it, like when it fully is like, when it's fully there, and you see that, and you're going to get a PDF tonight for tonight's class, because we're still teaching a class. I'm just giving you all the little bells and whistles, because it's the new year, the new launch, and here's what to expect for Spindle TV exclusive into the future. And there's going to be some obstacles or hurdles or something and all, and little glitches and all, but I've got it in a way. I spent the last 2 weeks of this break preparing for the next 16 weeks of classes and everything, and curriculum and all. So it's going to be amazing, I think. And tonight, our first topic of the night is going to be speeds and feeds, the principles of speeds and feeds. And it's going to, we're going to be hopefully the goal is that with what you learned tonight, you'll be able to start to build your tool database. So with that being said, the first thing I want to do is let's actually open up the tool database in Vectric. Now, some of you may just be beginning. Some of you may be just downright experts at everything. You know, the Vectric software, CNC machining, all of that wonderful stuff. And the and you may have mastered the tool database and what Vectric kind of gives you the opportunity to do, or you may be like, shoot, man, I still don't even know how to add a tool to the tool database kind of thing. Hopefully today, right now, that's going to change, and you'll know how to, you know, add things, tools, and then you'll know like settings and stuff like that. So let's first talk about the tool database. And I'm going to move the guys over to the side. Hold on a second, guys. I'm going to move you all over to the side here. How you doing? You're going to be visible and all on the side, but I need to be able to kind of what side do I like y'all on? Let me see. Can I put you on the right side? There we go. I'm left-handed, so I got to see things on the left side. But can everybody in the chat let me know, are you able to see the tool database cleanly? And I'll make the tool database bigger. I think it'll let me make it bigger. Come on, tool database. I think should take up the full screen. So let me know you can see in that. If you're not in high definition on your YouTube channel, there should be a little gear cog at the bottom. I am streaming in high definition, so there should be a little gear cog for settings. And then you might, if you're in low resolution, you know, like 720 and all, switch to the high resolution 1080. And it should like be a night and day difference on your view with being able to see things on the screen and stuff like that. And before we get kicking onto it, let me just say something to the guys on screen. So Keith, real quick, I'll start with you. How was your New Year?
Quiet. My wife's up in Canada, so I just spent it at home with the dogs.
Outstanding. And let me put in my earphones so we don't get any echo and all that stuff, because I forgot to put it in. Give me a second. Give me 2 seconds. Okay. Can you still hear me, Keith?
Yep.
Okay, wonderful. So now we shouldn't get no feedback for anybody. Okay. So anyhow, I'm so sorry. Could you repeat that again? I apologize.
Yeah, I just said it. My wife's up in Canada, so I was just home with the dogs.
Oh, wow. Okay, nice. I love Canada. I get to travel. I haven't gotten to travel there in a while and all, but I used to go there twice a year for woodworking shows in a place called Hamilton, Ontario, Canada. Okay. And I forget there's another place outside of Hamilton, but they used to have woodworking shows for one of our vendors. A Digital Woodcarver has a store. One of our vendors is in Canada that for our Canadian customers. And yeah, it's pretty cool. So that's nice. Well, hopefully she's not freezing to death up there. Lord, it's cold.
Yeah, it's been cold, snowy.
Yeah, absolutely.
But that's cool. That's where she's from. So she went to visit family. So
nice. Okay, wonderful. And JR, how about you, buddy? How was your New Year? How was your Christmas and everything? Everything good?
All quiet, which is kind of the way I needed it.
Yes, sir. Yeah, absolutely. And Kevin is in the background working, so I'm sure he'll when he pops in, we'll see how he's doing and stuff. All right. So here's the deal, ladies and gentlemen. So just to give you a little rundown on your tool database. On the left side, of course, you have your tools. And at the top on the left side, there's a box across the top that says material. And some of you may just have, a default, tool library here with no specific material separated at all. Nothing for plywood or pine or poplar or oak or walnut, nothing like that. And your bit speeds and feeds and everything will change depending on the type of materials that you're cutting in. Cutting in walnut versus cutting in pine or acrylic, it's different speeds and feeds and things, so for the most part, the one and done settings, like when I click on a particular tool in the tool database and it shows the settings on the right side, I may have a good standard tool library that is just, it's good for a variety of materials. I can make some minor adjustments and everything, and it gets me by. But ideally, what one would want is eventually they would want to start setting up their tool library by adding in different materials. And then when you add a material, let's say I add a material for pine here, and I click apply and everything. One of the things that you'll notice immediately is when you set up a material on the left side, all your tools are there, but they're grayed out, absolutely grayed out. So you can't actually use them in a toolpath at this moment for that material and all until you set it up. Now, when you click on a tool and everything over here in the geometry, it's going to say copy settings from. So it's saying, hey, this tool is established. Where do you want to copy the settings from? And most of the time you're copying, this tool, which is the one you actually have selected over there, right? And you're copying it from this machine and this tool library, right? So what machine I might have, a variety of machines set up. So I have machines for 1824, 2440, 4848, and 5100. And I have different tool databases for each of those machines. Because the speeds and feeds vary for each of those machines, right? And so it's asking me when I say, hey, I want to set up this material, I'm in my 1824 tool library. So I'm actually making a change in that library, not the 2440, not the 4840 to the 51, but this 1824 machine. So set up your machine. We'll talk about that in a second. But I'm in this library and I'm adding a material now to this library. And so I want to copy from this library and from the default tools, I want to copy from there. So when I hit copy, it's going to pull that information over. Now, this is where I make my adjustment or my change if it's warranted. So is my speed and feed and step over and everything still the same for this material as it was in the default, or does it change slightly? Did we figure out some adjustments and stuff to make? So let's say that for this 1/4 inch end mill, I'm going to run 18,000 RPMs, and on the 1824, I'll run it at 65 inches a minute, and the feed rate is 65 inches a minute, but the plunge rate is going to be half the feed rate or less. That's the rule of thumb. Half the feed rate or less. Typically, it's going to go to, I generally default to half the feed rate. The plunge rate is half the feed rate. So it reduces my runtime dramatically and everything. The only time I'm less than half is if I need to plunge delicately. What I mean by that, drilling operations. So, and or it's a small bit, maybe a 1/16 of an inch end mill, and I don't want to, plunge. I want to take a slow plunge so it has time to remove the material without snapping the bit in half because it's like a little needle, whatever the situation calls for. Now I'm going to generally set my default settings in the tool database to half of the feed rate. The plunge rate is going to be half, and then when I'm actually creating the tool path, if it is a drilling tool path, I'm going to probably edit the tool in the tool path so it doesn't change what's in your tool database. It only edits it edits the tool for that one tool path. And I'm probably going to slow it down because when I'm boring my holes, if I come down too fast, there's what's called deflection. Bits do deflect. And what happens is if you come down too fast and it can't remove the material fast enough, maybe the tip of the bit is a little dull, or maybe it's a little clogged with some pitch and resin or something. When it comes down, it will slightly deflect and then it will straighten itself out as it makes its plunge and all. And what you get is what's called a Wallard hole. And that is an actual term. It's not just a redneck term. It's a Wallard hole. So you'll get where it's Wallard out, but then you'll look down, and about the first pass, about the first 1/8 of an inch, it's Wallered out, but then you'll see a nice straight hole below and you'll be like, why is it doing that? And everything. It's because there's deflection. The bit's deflecting, So on that drilling tool path, I'll probably slow down the plunge rate to maybe a 10 or 15 or something, so that, you know, I get a nice plunge to minimize my deflection. So the tool pass might warrant that change, but I don't want to permanently change because I'm not drilling just with that bit. I'm not drilling all the time. I'm cutting, carving, you know, clearing and all that stuff. So I have my half plunge rate, half of the feed rate is my default. And then I'll make adjustments to that plunge rate if I need to for whatever tool path might require it, that kind of thing. So the only time I'm not half is, again, if I've got a small bit and I don't want to be, maybe I'm running 100 inches a minute. I don't want to be plunging at 50. I might, you know, plunge at 30 or something like that, because I just don't want to take a chance of breaking that small bit for whatever reason, because the wood's dense, you know, that kind of thing. So I'll probably slow it down. Right. So that would be the only reason I'm not at the half setting. But anyway, I'm digressing here. So we make that adjustment at whatever adjustment it might be and everything. It could be to the feed rate, the plunge rate. It could be to the RPMs, to the pass depth, whatever it is for that material. When I hit apply, now that one tool is lit up. And eventually, you know, you're not going to sit here. Some people they might sit here and they might have their notes written down and they're just going in and changing all the tools at once. But probably what's going to most likely happen is you're going to just kind of set the tools that you most commonly use all the time. And the cool thing about this is if I right click on the screen, I can hide the unset tools. So it's only going to show me the tools that I've actually set. Okay, it's going to get rid of all the clutter and everything. So as I set my tools for that pine material and the feed rates and the plunge rates and all that stuff for each tool and everything that I work with and stuff, then I can hide those unset tools and stuff. And now I have a nice little group of my tools for pine, and I'll do the same thing for walnut, for plywood, birch plywood, or, you know, for poplar, or for, you know, whatever, right? You know, Purple Heart. And I'll start breaking my generic tool database up into nice sections. So that way, when I set up a job and I'm carving on pine, I can go to my pine library and my tools are already set. I know I'm going to get great cuts from them and everything. Now, aside from that, you know, setting up the tool database and everything, let's talk about how you add a tool. So let's say that I just get a new tool and everything. I do want to add it to my general tool database, but I also want to, you know, copy it over. I will generally add it to the general tool database, and then they do exactly that. I will copy it over using that, select it, go into Pine, and then I'll copy from here and all the settings and stuff. So in the main tool library, if I need to add a tool, if it's a general tool, it could be a bowl and tray bit. That's called a radiused end mill, flat on the bottom, radius on the sides. It could be a ball nose bit. A ball nose bit means that the shank and the tip are the same diameter. So if it's an 1/8 inch ball, the shank is an 1/8 inch. If it's a 1/4 inch ball, the shank is a 1/4 inch. That's a straight ball nose bit, ball nose. A tapered ball nose means that the shank is wider, could be a 1/4 inch, could be a 1/2 inch, could be whatever, and the ball is smaller and it tapers into that ball. So there's a side angle that gets accounted for. A straight ball nose, there's no side angle that gets accounted for. So if I calculate a 3D model cut with a straight ball nose, but in my router or spindle at the machine, I'm using a tapered ball nose, my cut's not going to look the way it's supposed to look, because it's not, the lines and the spacing and all is not counting for the offset angle, right? So there's a difference. So if it's a straight ball nose, a tapered ball nose, a end mill, a V-bit, an engraving bit, and things, then you can simply just click add, the little plus sign at the bottom. You can choose what type of tool it is, and then you can come in and set the settings for that tool. So that's how you add a tool. At the top, when you change the name, if you click on to edit the name, be sure, and I don't know why Vectric sets this as a default, but be sure to uncheck this box before you click OK if you're changing the name, because this box is set as the default for radius end mill, meaning every time you add a radius end mill, it's going to default to that name that was set, whatever it is. You know, if you put in a white side, you know, blah, 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 this and that, it's going to name every radius tool that you add to that white side, blah, 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 this and that. You don't want that, right? So make sure you uncheck that. And by default, they have it checked. I don't know why, but it's crazy. You choose the type of bit it is, you set the settings, and you go. Now, if it's a form tool, meaning that it has a special profile to it, a OG bit, a rope twist bit, a box core box bit, a T-slot bit. There's quite a lot of different types of bits out there, but if it's got a special profile to it, then that's called a form tool. And when you're adding a form tool, you have to draw the right side of the actual profile of the router bit to scale. Okay, so if we were looking at a Whiteside 2050 1/8" roundover bit, just as an example. Let me get out of millimeters here, inches. Give me a second. I'm just going to go 5 by 5 by 0.75. If we were looking at an 1/8" Whiteside 2050, that bit has a diameter, a width. It's got a cutting width of 3/8 of an inch. It's got a cutting height from the top of the radius to the bottom of the bit of 1/4 of an inch. And then it has a 1/16 of an inch straight line up. So if I come in here on a rectangle and all, my radius would be an internal radius. It would be 1/8 of an inch. And my width would be that 3/8 of an inch diameter. And my height, for the height, I would probably just put a 1/2 inch because I'm going to be cutting it and all that stuff. So 0.5. And when I draw this, it's going to create this look right here. Now, first thing that I'm going to do is I'm going to come into node editing. Let me click close on this and go to node editing. And I'm going to cut the bit right in the middle of that bottom line. And then I'm going to come over here and I'm going to cut this line probably in the middle too. And I'll end up getting that line to whatever the height is on my actual tool. But I'm going to now delete that whole top left half. I need the bottom right corner. Now on the Whiteside bit, from the top of the radius to the bottom of the bit is 1/4 of an inch. And currently right now, this is 1/8 of an inch. If I were to come over here and I were to measure vertically from this point to this point, let's make this a little smaller so everybody can see. It's 1/8 of an inch. And so what I have to do is I have to go back into node editing. And on the bottom, I need to right click on this node and cut the vector here. So it separates that line from the rest of the part. And I need to actually move that down. I'll make a relative move, negative 1/8 of an inch, 0.125. And then I'll select both of the parts, get out of node editing, and I will join them with a straight line. Okay. So now I have the profile, the right side profile of that bit. Now from the top here, if I measure from here to here, I'm at 1/8 of an inch. And I believe, if I'm not mistaken, I don't have one in front of me. that straight line up on the white side 2050 is either an eighth or it is a 16th. Let's assume for right now that it's a 16th of an inch. All I would do is I would do it one of two ways. It's an eighth of an inch. I just verified that. If I ever need to know and I didn't want to measure like the actual with the measurement, the drawing and all, I could just go to the measure tool. And if I click on this, it'll tell me what the length is right here and everything on that span. It'll tell me the length and stuff. But if I go into node editing, I could very simply grab this top node, pull it straight down just a little bit. Don't let go of your mouse. Just pull it down, but stop the movement and type in 0.125 and hit enter. Let's not do that because I only needed to go pointless. I need to go a 16th, not the full length. So let's try that again. So let's pull it down. 0.0. Let's try that again. 0.0625 and hit enter to pull that down. And what I did was, if you move a node in any direction and then you type in a number, a value while you can stop the movement. But if you type in a value and you hit enter, it will continue that movement in the direction that you pulled the node by that distance, by the number of the value you typed in. So if I were pulling this over to the right and I said 1 inch, it would pull it over an inch. And that is an inch on this 5-inch board. But you know what I mean? So whatever direction you're pulling it, you can type in a value and it'll just move it that distance. So in our case, I just moved that line down a 16th of an inch. Now, there's other ways I could have done that. I could have, cut it loose and then clicked on it and went to the size tool, typed in the 16th of an inch and hit apply, and then just rejoin the part back together. There's all kinds of ways to get from point A to B and everything, whatever it is that you want to do. And so in this case, now I have the right side profile, and the profile has to be joined. All the lines got to be joined. It's got to be one vector. So in the join tool, it's got to say one open vector. It's got to be selected. It has to be selected before you open your tool database. You cannot open your tool database and then try to select it after. It doesn't work. It won't let you. So here, I'm just going to go up here and go to the menu tool database here. That is selected in the background. I can now come in here and I'll go down to my form tool category or my roundover. I actually have a tool category for roundovers. Now the white side 2050, I've already got it in there, but I'll do it again. We're going to click on the add here. We're going to come down, and as soon as we click on form tool, don't you argue with me. Hold on a minute. I did not finish the join, so it's still two separate lines. I showed you the join here, but I didn't actually hit the word join. There we go. Now let's go in there and try that again. I was on such a flow too. All right, here we go. So we're going to select that. As soon as I click on form tool, it's going to come in and it's going to automatically draw the left half of that tool. It's going to put in the diameter automatically, and it's grayed out. You can't change the diameter because you drew that right half to scale. So when it creates the left half, it's assuming you drew it to scale. So whatever that left and right together, that diameter is, it's in there. From there, we can come in and set the flutes. Now it's saying, hey, you already have a tool like that here, and it actually found it and everything. Sometimes it doesn't, or it may or may not, or whatever, but it's saying, do you want to copy the settings for this tool from here? I could copy that over for sure. Now on a roundover, typically we want the roundover to actually take the full plunge all the way up to the roundover, because it's generally cleaning an edge and everything. Now sometimes you might be running a dense piece of wood, so you might take it in 2 passes. But the second pass is going to be the full cut of that 1/4 of an inch all the way to the roundover edge, and stuff like that. So typically the pass depth will be that. The step over is going to be 1/8 of an inch. So from the outside of the bit, let me come over here. from the outside of the bit to the inside of the bit on that round over, that's 1/8 of an inch. And so that's what the step over is going to be. 33.3% of the bit, 1/3 of the bit is stepping over. I'm going to run that bit at 18,000 RPMs. I'll probably, round over, I'll probably plunge a little bit slower because I am, doing a full plunge on it. But I'll run it 45, 50, 60 inches on my smaller. This is my 1824 library now. You got to keep in mind. If I was on my commercial units, my 3648 or 4848 or anything like that, I would probably be running that bit at 75 to 95 inches a minute or more in things, because it's just doing an edge profile and everything. So, but for this 45 inches a minute, I'll be plunging instead of half. In this case, I'm actually plunging a little bit slower, 15. And then up here, I don't want it just to say Form Tool 3/8. I want to come in and change the name, uncheck that box, mentally be aware of that. And then I can come in and change the name. And so this would be my Whiteside 2050 copy, since I already have one in there. And then click OK. And it will add that to your round over and all once I click apply. And of course, it moved it up there for some odd reason. Now I got to drag it down my tool library. If you drag a tool, if you hold it at the top or the bottom, it'll cause the tool library to shift, in things, sometimes slower, sometimes faster, and things. Come on now. Get down to it. And then if you move and start talking about it, there we go. All right, so I just want to drop it into that category. And I'll click apply again. But now I've added that tool to the tool database. So a form tool that has a special profile that's not any one of these type of tools: ball nose end mill, radius end mill, like a bowl and tray bit, V-bit, engraving bit, tapered ball nose, a drill bit, a diamond drag bit, threaded mill is, you don't need to draw that profile. A laser cutter, if it's any one of those, you can just add the tool, put in the geometry, and save it. But if it's a form tool that has a special profile, OG bit, rope twist bit, keyhole bit or key slot bit, or not, I shouldn't say keyhole bit because that's a special type of tool. But anything with just a round profile, round overs and things like that, beading bit, that kind of thing, you have to do it as a form tool, and you got to draw the right half. All right, so now we know how to add a tool to the tool library and everything. We know how to add form tools and regular tools and stuff. Setting up our material. Let's say I've got this tool set up and everything. Now I can come over here to my material. And again, all I have to do is just select it over here. It's grayed out, but I'm going to copy the settings from this library, and it'll bring those settings over and everything. And then I can hit apply, and then it'll turn it on. And then once again, I can hide my unset tools. So I have my, set tools just showing, right? So I could do that for my pine, my poplar, my walnut, and all that stuff. Now, once I have all my tool library and all I'm doing is copying them over to the other materials, and I'm making minor adjustments based on what we're going to learn tonight on speeds and feeds, the principles of speeds and feeds and things. But this is, managing your tool database, and of course, backing it up, upload it to the cloud and all, so it stays synced on all your computers that you have the software on and stuff like that. And also, by the way, if you have teammates, if you have a business with teammates and everything, you can be the master tool database where all the changes and updates and speeds and feeds get changed. But then you can actually share your tool database with a particular individual and everything. So it's called a remote tool database. So you can host it on a URL, and other people can pull from it and all. But whenever you make a change, it changes everybody's, right? So you can host it and all. Now, you can learn more about the tool database and hosting and everything by going into the manual and reading it and just kind of watching the videos and stuff like that to learn more about it. That's not what tonight's topic is all about. But yes, if you did have a business at all and you were the master of that tool database. But you could host it to others that, where they can benefit from your settings and all that stuff as well, if they're on your team. Okay. So that's our tool database. Now let's talk about the actual speeds and feeds and things. And the first thing is give me just a second. 1 second. Nope, not that one. Hold on 1 second. There we go. All right. Let me really quickly, I'm going to turn off screen sharing so the guys and I can kind of fit on here and y'all can see me. I'm going to bear with me a second, guys. I'm going to kind of go like that. Hey, welcome back, Kevin. Kevin, how was your New Year, sir?
Uneventful. Dealt with a shoulder surgery, and it's all good. Be back carving here in another couple of weeks.
All right.
Can't
Well,
lift anything right now.
I hope it heals quickly for you and everything. Hate that you had to go through that one, but I can totally understand. Well, the perfect time while you're kind of down and out and you can't move any material, it's a great time to kind of just start sucking up information, wherever you can to learn and all that cool stuff and everything. So hopefully the honeydew list isn't that long, so you have a lot of time that you can start checking out cool things you want to do.
No, I've been doing a class with Kyle and following it, reading your bunch of your YouTubes, and just trying to get the bugs out of all my Aspire training or design work, so I don't have to call you.
Absolutely. Yeah. Kyle's master classes are good. So, that you'll learn a lot from them for sure. All right. So we've got JR's question here. If we have multiple machines and materials, would the tool database be completely independent files for each machine and material? Yes. 4 different machines, 4 different materials. Yes. So in your tool database, when you are in here, your tool database for your different machines, you will be setting up a machine, each machine, and we'll go into the setup here. You'll be setting up a machine, your post processors for that machine, your accelerations and all that stuff. And for each machine, the tool database is for that machine. So if I switch to the 4848, notice that, oh, you can't see. Hold on a second. I'm an idiot. Hold on. 1 second. I forgot that I had us on live and Runaway. All right. Might be a good movie. Okay. So in the tool database, you will have all your machines set up. And the machine manufacturer, the accelerations and things, and then the post processors for that machine. You'll have that machine set up and all, and then with that machine, the tool database is completely independent of that machine and the material and all too. So let's say that I have my master library here for my 1824. When I switch over to my 4848, you'll notice that all the tools go gray. My tools are my tools. I still have my tool library and everything, but they're not set for that machine. They're set for the 1824. So if I were setting here, it's going to, once again, say copy this from whatever this tool from, this library, and this, this, whatever it is, whatever material and all I'm copying from. And then when I copy it over, if I make any changes, this tool I might be running on my commercial machine. I'll probably, I'd be running it, let's say, 125 inches a minute or something, and plunging at 75 inches a minute, whatever the case may be. So I would set those settings and everything and apply them. And it's only going to apply those settings for that material for that machine. So it's independent. It's all independent of one another and everything. Okay. All right. So that is the answer to that question. All right. Let's talk about speeds and feeds a little bit here. First things first is really, let me get, I wanted to kind of close out of this for just a second and come back here. I got to fix my lighting again so the lighting is not in my eyes and all that stuff. But let's kind of let's step back for just a second for those of you that might not be might not even know what the topic and everything is. And you're all here, by the way. So I know the camera's here. Forgive me. You're all here with the chat and everything and all, and the guys and stuff. So I'm just kind of, I know this is making eye contact this way, but I'm also making eye contact this way. So anyway, so first things first is let's talk about speeds and feeds. Okay. Speeds and feeds. Speeds refer, the word or term speeds refers to how fast the router bit is spinning, the RPMs of the spindle or router, how fast the bit is spinning. Feeds, such as your feed rate and your plunge rate, are how fast the material is getting pulled and pushed and plunged into the material. Okay. And typically the plunge doesn't really play too much of a role. It's typically the feed of the X and Y, that movement and everything there. So how fast that bit is moving, getting pushed and pulled through the wood, that is your feeds. So speeds and feeds. Now, when you have your combination of feeds and speeds, your RPMs and your feed rate and everything, if you couple in your number of flutes on the router bit, if it's a 2-flute upcut spiral bit or a 3-flute tapered ball nose and things like that, these items, feed rate, spindle speed, RPMs, number of flutes, the equation, the math, and we're not going to be into the math too much into the math tonight or any of that stuff. And that stuff we're going to be learning just the principles and all. What you get is you get the chip load of that tool, and you basically take your feed rate and you're going to divide that by the RPMs times the number of flutes. Okay, so in math, in parentheses, RPMs times the number of flutes. Those two things are going to be multiplied together first to get your value. And then you're going to take your feed rate and divide that by that value. Okay, the value of the RPMs and the number of flutes multiplied together. And the answer, the result of that mathematical equation is your chip load. Okay, and the chip load is the thickness of material that gets removed by each one of the teeth or flutes of the router bit. Okay, so each flute, also referred to as cutter or teeth, they all mean the same thing. Each tooth, as that bit is spinning, is taking material, and that material, the size of that chip that it takes is called the chip load. The chip load of that cutter, right? The chip load of that cutter. And if we're taking too little of a chip load, we're getting insufficient cuts. If we're taking too much of a chip load, on a cutter and everything. We could be, in the process of causing chatter or breaking bits and things like that. And so if the bit is spinning too fast, but it's not moving feed rate, it's not moving through the wood fast enough, then it's not actually cutting, it's not taking any chips. It's what's called rubbing. It's rubbing. And rubbing builds up heat. Now, in a show of, just so I don't sound stupid and all, in the chat, how many of you have ever seen a box turkey call, whether it be online or in person or anything like that? A turkey call that it's a box, it's got a handle on it. You rub the handle where the two pieces of wood rub together, and it makes that turkey call, like, whatever it is. Now, I can't make a turkey call, but anyway, if you're familiar with the term, or if you know what a turkey call is, let me know in the chat and everything. Hey, Doug Fushi, how you doing, buddy? Now, the reason why I say that is, with the turkey call, when you're rubbing that wood lid, on that box, that lid box, it makes that squealing noise, whatever it is, whatever that call makes, depending on the resonation of that box and everything. Well, if our bit is spinning, but it's not getting fed into the material, it's rubbing. And if it's rubbing, a couple of things are happening. Number one, heat is building up on the bit. Heat is what dulls a router bit. All right. And so you're killing your bit if you're not going fast enough and it's not taking the proper chip load. But also what's happening is that bit is screaming. If you're ever got a cut, if you're ever doing a cut and that bit is just welling at you, like a hungry puppy at feeding time, or, a pig getting, picked up by its hind legs, whatever. If that thing is whining at you and all, typically what's happening is that bit is rubbing, it's not cutting. So you're not going fast enough and your bit's spinning too fast. So you can either do a combination of two things or one or the other. So you either slow down the RPM so the bit can spin slower. So even though it's gooing slower, the teeth are spinning slower so they can still take a nice chip. If they're spinning too fast, they're rubbing. They're not taking anything. They're just spinning too fast to capture anything, because you're going too slow. But if you slow down the RPMs, it can start to take a little bit of a chip, and that can quiet it down, reduce the heat buildup and things like that. But if you can also increase the feed rate. So you can do a combination. You can slow down the spin, the speed of the bit, and increase the feed rate to kind of reduce that whining, that heat buildup, and get those nice chips flying. We want to see chips flying. We don't really want to see dust flying and everything. The chips are a good thing because the heat that would generally get generated and all by the bit cutting and all gets dispersed. It literally, the heat gets taken away from the bit by the chips. And when it gets pulled away from, the bit and the chips and everything, it's keeping the bit cool because the heat's getting thrown away, and stuff. Now, if we have an improper feed rate and speed combination, we are rubbing, we're building up heat, we're building up friction and things like that. It's causing, you're going to see noticeably, you will see fine dust versus chips. Now, in the instance of MDF makes fine dust. I mean, it is, very rarely when you're carving a material like an MDF, that composite type material, MDF, very rarely will you see, you'll see chips and all, but a lot of times you'll see a pile of dust and all. And MDF is very known for the dust, and always try to wear dust masks and all, because MDF dust is just, albeit terrible. But you'll see a big pile of dust, generally with MDF and all. But in your woods, if you have a dust pile, powdery type dust versus chips and everything, your speeds and feeds aren't set up properly for that tool, for that material. You need to make some adjustments and everything. Okay. Now I don't want to get, well, we're going to talk about the principles in an orderly fashion to make it make sense to you. But I just kind of giving you the general idea of what speeds and feeds are, what chip load is. So speeds and feeds, final summarization. Speed is the RPM, the turn of the bit. Feed is how fast the bit is moving. The number of flutes of that bit, along with your feed rate and your plunge rate, the multiplication, RPMs times the number of flutes. Multiply that first. And then you take your feed rate divided by that value. That gets you what's called your chip load. And there's chip load charts out in the world that, say, hey, for this size bit at this RPM and this material, this is what your ideal chip should be. Someone's done all the math and science and all, mostly the, the bit manufacturers and everything. They've kind of done all the research. And so they give you the recommended, feed rates and plunge rates and all that stuff. And if they have it and your machine is capable of meeting it, wonderful. Go for it and all. Now, so hopefully that will let you know. In the chip load, depending on who you're talking to, right? The chip load could be referred to as the bite, right? How much that tooth is, right? The tooth, the bite, the tooth of the tool, how much of a bite it's taking and everything. Basically it's how thick that material is that's getting removed by the tooth, the chip load, right? And that's the word you'll hear more than anything. Now, basically what's the purpose of chip load and what's the purpose of having the right speeds and feeds and everything, right? It's efficiency. I had it. The efficiency of it all is, one, reduce noise, reduce heat and friction buildup, causes less burning on your material, on your finished project that you got to sand out or whatever, that ugly burning, unsightly burning and stuff like that. The less burning, less heat buildup, like killing your router bits, where a router bit should last you months or years. It's lasting you days and weeks, because you're just burning them up, like crazy and stuff like that. Your finish quality. The finish quality is the big efficiency matter. So right off the CNC, if I can get a stellar cut off the CNC where I have very little bench work to do, very little cleanup, and there's going to be some bench work. There's going to be some sanding. There's going to be some of this and that before it's finished ready and stuff like that. But if I can have an efficient run time and get excellent quality of cut on that carving for that material or this material and all that, because I have taken the time to really hone in my speeds and feeds, then it makes the world go round so much easier. It all comes down to, that bottom dollar, how much time you spend on doing this or that. You're either spending time, sanding, those burn marks away, or you're spending money on new router bits because you all the heat buildup just killed the bits, and all these things lead to inefficiency in hobby, life, business, personal, whatever, right? So the purpose of it all is just efficiency in your cut, your quality, your money saving, money making, all that stuff. Now, the main thing, bear with me a second here. The main thing I want to talk about is no math, no memorizing numbers and charts and all that stuff, the feeds and speeds charts. The core principle of it all. Now, everybody should have, in some form, fashion, or another, at their CNC machine in the shop nearby, either at the machine or at the computer or whatever, you should have some form of notepad or notebook or something. Or if you're in the electronic age and you're just into your phone or your tablet or whatever, you should have a running kind of like, not journal, if you will, but basically it could even be a spreadsheet, whatever, I don't care. But you're visually I pointed to the ear as I said visually. You're visually and audibly looking and listening to the cut, the performance. There is a lot of math and science and all that behind, carving and stuff and chip load and this and that and everything. I mean, you could get so deep and technical in it, but the core of it all, 90% of it is audible and visual. You can listen and you can hear when a bit is struggling. You can hear when a bit is cutting beautifully. You can hear, chatter, on the machine. You can hear all of these things. Your ear is a lot faster and a lot better at discovering issues than your math or your eyes and things like that. So here's the deal. Okay. Long story short. All right. What this lesson tonight is and is not, basically, right? What it is not and what it is. This is not, I'm not going to, at the end of the class, give you a speed and feed chart. Okay. So this is not a bunch of charts and not memorizing numbers or anything like that. Okay. What this is, it's going to give you hopefully a way to understand what's happening right in front of you. Okay. At the table, when you're doing cuts and when you're running bits and different materials and all that, I'm hoping that it will give you the understanding of what you're seeing and what you're hearing and how to adjust accordingly. Do I speed up? Do I slow down? Do I turn down my RPMs? Do I increase my RPMs? All of that stuff. Okay. Being able to kind of listen and hear and see what's going on, and then know how to make that adjustment to meet the need that you need to meet, right? To get that optimal cut, to get those nice clean finishes. So here's the core idea of it all. All right. If you understand the relationship of the speed and the feed and the sound, what you're seeing, what you're hearing versus what's actually happening in the software and all, then the understanding of the relationship of speed and feed and, your settings and all for your bits and all will keep you from guessing and also keep you from having to spend more time cleaning up not so great cuts, all those little fuzzies and things like that. And some woods are going to cause fuzzies and all that, but how to prevent the chipping and, the flaking and the veneer damage and all the little fuzzies and all the little sanding and stuff. We want to do our best. We got an efficient machine there. If we run it efficiently, we should be able to minimize our hands-on time a lot. So every person in this group, in this class, bear with me just 1 second. Every person in this group, in this class, is running a different software, a different CNC machine, different router bits, and everything like that. So here's the core of it all, kind of just like the general things. We've already talked about the speed, RPMs. We've talked about the feed, how fast the bit is moving, right? But then we have our bit types and size that plays a role too. How much material can we safely remove, with our bit? I probably will run my quarter-inch end mills, let's say at 18,000 RPMs. I might be running them, 125 inches a minute on my, one of my larger machines. But if I throw in a 2-inch surfacing bit, I'm definitely not going to have that bigger bit spinning that fast. It's got to slow down a lot. I'm probably going to be about 13.5 or something, on the RPMs. I might back it down. I'll probably be running a little bit faster, maybe 90 to 100 something inches a minute or whatever, depending on the machine. Again, I don't want to get too specific on numbers because it'll change from hobby machines to mid-grade to, expensive, $100,000 machines and all that stuff. Rigidity and strength and power of the machine plays a big role in it all. But So the bit size and type plays a role with our feeds and speeds. You know, a small 3-flute tapered ball nose, the flutes, by the time, like let's say a 16th inch tapered ball nose, by the time those flutes get to that 16th inch ball, 32nd inch radius and all, I mean, those flutes, the gullets in between the flutes is small. They can't really take too big of a chip, you know? And if that bit is spinning, spinning, it can't take hardly any chip, you know, and stuff. And so we're going to be building a lot of dust, you know, more than chips and stuff. So those smaller flute bits and all, I might be running that at a decent feed rate, but I might be slowing it down so the little flutes have time to, you know, take some of that material as it's traveling through and stuff like that. But if it's a big bit, you know, big old straight flute 1/2 inch end mill, you know, or something like that, I'm not going to be feeding that too slow, because it's like a bear trying to, you know, grab, you know, all the fish out of the water or whatever, just slow. I mean, I need that thing moving, you know, I need it, you know, but not too much. I might be running that. And again, numbers, I'm not trying to get specific on numbers, but, you know, I could probably be running that at, you know, 15, 16,000 RPMs and stuff, you know, and, you know, a decent feed rate and all. But I'm listening, observing. If my bit is shaking through because it literally can't keep up with removing the material as fast as it's getting pushed and pulled through there and everything, it's going to be chattering. It could snap the bit. It could literally, the force could be so much that it pushes the wood out from under the clamps and everything. Just catastrophic. You know, if it comes, the clamps come loose, all of a sudden the board's like might get sucked up on it, depending on if it's an upcut spiral, whatever. All of a sudden now you got this board flipping around. It can go crazy, right? So all kinds of crazy things could happen if we're not, you know, if we're not paying attention to stuff. So bit type and size plays a role in all this stuff and everything. And then the last kind of you know, core key detail is the material. Is it a soft material? Is it a hard material? Is it a layered material, plywood? Is it a plastic, a composite, a carbon fiber, or whatever? So the material type is going to play a role. Is it a non-ferrous metal, aluminum, copper, brass, titanium, or bronze? With that, we're going to be taking shallow cuts, you know, at a fairly slow feed rate. You know, if our machine it's a wood router, but we have the ability with metal milling bits and all, we have the ability to mill non-ferrous metals. We just have to slow things down and take lighter cuts and all that stuff. So the machine, because it's all based on, again, the strength, the rigidity, and the power of the machine, what it can and cannot handle and things. And so now with the different materials and stuff, each bit, this is where it could almost kind of become overwhelming. I got hundreds of bits in my tool database, and each one of those bits act different or need to cut differently at different feeds and speeds for Purple Heart, Wenge, pine, poplar, plywood, mesquite, which is like a brick, you know, and things like that. Plastics, composites, carbon fibers, whatever the case would be, there's going to be different settings and everything. Now keep this in mind, and this is a key thing with regards to bits. Wood routing, wood and typical plastics too, wood and plastic routing. 3 flutes or less is typically what you want to. Anything over 3 flutes, those are metal mills. A 4 flute bit, a 5 flute bit, blah, 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 6 flute bit, and all that. Now you're metal milling and all that. They're not efficient and they're not good for wood routing, even plastics and composites and stuff. 3 flutes or less. You do not want to be over 3 flutes. So if you have a 4 flute 1/8 inch end mill, gold tip CRN coated from Amana Tools, you know, and everything like that, that is an efficient tool for non-ferrous metals, but it's not an efficient tool for cutting pine, poplar, and all that stuff, right? You know, walnut and everything like that. The 4 flutes, great for metal, non-ferrous metal milling, not great for wood and composites and stuff like that. So 3 flutes or less. Just keep that in the back of your memory when you're buying router bits and all that stuff. Okay. All right. Now, so speeds and feeds, your spindle RPMs and your feed rate, your bit types, and your material. Those are the core. That's the core of CNCing and speeds and feeds and everything. All right. Now, we want to think of it like this. I'm not going to harp too much on the speeds and feeds. We just had a big, discussion on that just a few seconds ago. But think of it like this: too fast of an RPM and too slow of a feed rate equals rubbing. Okay, that squeal. And here, let me say it. Let me say it a little bit better, a little bit not well better, but different. There's two sides of the spectrum. Okay. If my bit is hollering and screaming at me and everything, it typically means it's rubbing, and therefore I want to slow down the RPMs and I want to increase the feed rate. That's one half of the spectrum. All right. Rubbing, high squeal, high pitch, slow down the RPMs, increase the feed rate. It could be one or the other or a combination of both. The other side of the spectrum, which is the side we don't want to be on, is if I'm breaking bits, if I'm shaking and chattering and everything on my cuts, if I'm pushing my material out from under my clamps, my bit is spinning too slow and it's getting pulled and pushed. The feed rate is too fast. Okay. I've got to slow down the feed rate and I've got to increase the RPM so I can take more material and everything. Right. So that side of the spectrum causes bit breakages, causes clamps to vibrate loose or whatever, causes material to get literally forced out from under your clamps. It causes chatter and things like that. So the too fast of an RPM, too slow a feed rate, rubbing. Rubbing creates heat. Heat causes burning on your material, dulls your router bit, melts your plastics and acrylics and composites, causes the fuzziness that you see in the bottom of the cuts and all the little fuzzies and things like that, causes fuzzing, and it creates a poor finish. Okay? Rubbing, too fast of a spin, too slow of a feed rate, causes those little fuzzies, poor cut finish, heat buildup, dulling router bits, all of that. So if you think of that, that's all the kind of the negative side of it, right? All right. Now, the chip load without the math, okay? Chip load, you can think of it two ways. Is it cutting or is it rubbing? Okay. If I'm rubbing, let me go the other way. I want to let's start positive this time. Is it cutting or is it rubbing? If I'm cutting, we're producing nice chips. Chips are flying, right? We are minimizing the dust and everything, unless it's like an MDF or something that's really dust prone. You can't, you just kind of can't get away from some of those materials and all that. But the sound sounds so smooth. It's not screaming. You're going to hear the bit cutting through the wood, but it's not going to be screaming at you. So it's going to, the cut, you can literally sense and hear that it sounds smooth. It's a smooth sounding cut. Okay. And it's consistent. It doesn't whatever. It's a consistent, nice tone, with the cut. It's just music to your ears in a sense. I mean, as far as what it could be, it's not, the Rolling Stones or anything. All right. Now, clean edges, right? Very little chip out, very little fuzzing and things like that. That's all the good side of, a good chip load, a good, speed and feed combination, right? Now, bad cutting or rubbing, the rubbing side of it all. I'm not going to harp on it again, but the squealing and the whining, the irritating where you just can't stand to be in the same room as it while it's carving a project and stuff like that. The burn marks that you got to sand out later and everything on your cherry and all that stuff and everything. If you're ever doing hand routing and you're doing roundovers and stuff, or you're doing hand routing and all of a sudden the edge, that nice roundover you just made or chamfer cut you just made burns and all, move faster. Literally you're the CNC, right? Move faster and all that. You got to move faster, or change the RPMs and things. It's the same as hand routing as it is with, CNC routing and all that stuff. But if you've ever done that, if you ever done any nice edge work and all of a sudden it's like, oh God, especially with cherry, it really burns deep and you got to sand a lot to clean it out. But anyhow, so the burn marks, right? That's the bad side of it. If you're doing composites, acrylics, I will say this. Cast acrylic is what you really want to aim to if you're doing plastics and acrylics. You want to really, if you can, you want to stay away from extruded plastics, right? Extruded plastics can easily chip, shatter, break, melt, and things like that. They build up when you're cutting. The heat, if your speeds and feeds aren't right, the heat melts the plastic. The plastic creates a molten ball on the tip of the bit, and then all of a sudden you've got to stop no need hold on, I just saw something. Yes, there are guides for chip loads. There are guides for Amana has them for their tools and all that stuff. You can just type in chip load or speeds and feeds and all the charts on Google will come up for you and everything. Don't ever apologize for asking any question. I just didn't see it, Kevin. But yes, there's absolutely charts everywhere. But that molten ball of plastic builds up, and all of a sudden now that if there's any cooling period and everything, that molten ball hardens like a rock on the end of your bit. Now your bit's running through this material, which is not running through, it's not cutting through. It's kind of just shattering it and just breaking its way through like an icebreaker ship, in the Atlantic, or in the Arctic. It's just breaking through and all that stuff and all because, it melted that plastic and stuff. So good speeds and feeds when it comes to plastics and all good results is really important. And then excessive fuzz and tear out, right? If we're rubbing, we're spinning too fast. The bit can't, it's rubbing. It can't take a nice cut. So therefore, what does it do? It takes whatever cut it can and it leaves a little behind, creating those fuzzies that you see, stuck at the bottom of the cut and all that stuff. And also on the edges, the upper edges of the cut, like if you're doing, pockets and profiles and mortises and all that stuff. But also tear out, tearing out and chipping and everything. So the it all comes down to basically, if you hear squealing, your bit's not cutting. Okay, you're rubbing, and things like that. And then your cut quality is going to be not as good as it could be. All right. So now let's talk about
lady.
Yes.
So if you got a high pitched squeal on 18,000 on a 1/4 inch bit, it's kind of a high pitched squeal.
Yep.
It's probably a 20-25 decibel over when it's not moving. Does that sound all right? Or
well, I'm not. I'm not good with decibels and all that stuff out here. But if you're squealing a high pitched squeal, you slow down your RPM. So if you're at 18,000, bring it down to 17, 16. You make adjustments in your software. Kevin, you happen to have OmniControl and Planet CNC. In your software, you have the ability to adjust your feed rate and your plunge rate on the fly. So while it's carving, you can literally slow down or speed up your feed rate by 10% increments. And your RPMs, you can slow down and speed up by 10% increments on the fly while it's carving. It's on the left side of your controller and everything.
You can do it. You can do it on Planet when you're carving.
While you're carving, absolutely, yes. And you can slow down or increase and everything and adjust and all until you get that nice cut. Now, if you go too much, 10%, 10%, 10%, all of a sudden the cut starts to deteriorate, meaning it starts getting bad looking. It's
smoking.
The squill might be gone, but it's bad looking. You went too far. Go back up. You got to make fine adjustments. That's why you can increase in 10% increments. Okay. So, and all that. But in your example there, the high pitched squealing, you're going too slow. You got to go faster.
Feed rate or RPMs?
Feed rate. RPM is you turn down your RPM. Okay. High pitch squeal, slow down the speed of the bit, the RPM. Speed means RPM, the spinning, speed.
Understand.
Spinning. Feed is how fast the bit is moving back and forth on X and Y and Z and all. Feed. Well, Z is the plunge, but anyway. So you slow down the speed, the RPM, you increase the feed when you have a squeal.
Got it.
All right, now let's talk about that. Let's talk about that a little bit. Go ahead.
On Planet, where do you make that adjustment?
It's on the left side. You have an icon right under your X, Y, Z, and A that looks like a router bit. That's your feed rate adjustment. And one below that, you have it looks like an icon looks like a speedometer, like a car speedometer. That's your feed rate. Oh, click on that and it'll open up on the left side. Okay. And underneath the X, Y, Z, and A position numbers. And then you have underneath the car speedometer, you have a router bit icon, which is your spindle speed.
You can click on either the speedometer.
You just click on them. If you click on them, you'll see 3 arrows. You'll see a straight arrow, a down arrow, and an up arrow, and a number.
Got it.
100%. 100% means it's running 100% of your current G code, what the G code is programmed for.
And that's
if you hit the down arrow, it's going to drop down 10% of the G code. 10%, 10%, 10% every time you hit that down arrow of the G code. Or the up arrow, 10% increase. The level arrow levels it back out to 100% of what the G code is programmed for. Okay? And it's the same for both. You click on the speedometer or the router bit, you'll see those adjustment arrows and everything.
Thank you.
You're welcome. All right, so let's talk about dull bits and burning bits and all that stuff most of the time, right? So burning of your project is typically caused by a dull router bit or insufficient, feeds and speeds causing heat buildup and burning. Okay. So it's typically, it has nothing to do with bit quality. Is it an Amana? Is it a white side? Is it this or is it that and everything? It has to more do with, improper settings for that particular tool, speeds and feeds and material, heat buildup, not bit quality, right? So heat buildup. So burning, you'll typically, it's not the tool. I could go buy a $23 speed tool, put it up against a $75 Amana tool any day of the week. I love Speed Tool, by the way. Anyway, I have no affiliation with them, but it has to do with insufficient settings. Burning, it's not always equal to a dull bit, right? So typically, again, heat and insufficient speeds and feeds will cause burning and all. It doesn't necessarily mean the bit's dull, but if you keep building up heat, that's where the bit's heading. Because heat is what dulls a router bit. But the common causes of burning, you're going to have, and a lot of this sounds like, it's a repeat and regurgitating of the same info. It's like, yeah, we get it. You said that like 100 times by then, but it's all the same thing. These are the different causes that, there's not just one cause that happens. The squilling is not just the one thing that happens. The burning happens because of the squilling, because of the heat buildup and the dull and they're all, tile up. So if something sounds like it's repeating, it's not. There's just different areas of it. So our burning, again, not always equal to, a dull bit. It has to do with, that bit spinning too fast, too slow, in proper settings and all that. But here are some of the common causes. So if the feed rate is too slow, that could cause burning. Okay. You're not moving fast enough through the material. The bit's spinning so fast, it's building up heat and it causes burning, right? The RPM could be too high, right? The bit's just spinning so fast, it's not really moving fast enough on the feed rate to keep up with that, the RPM. So all it's doing is just rubbing. It's not taking any chips because it's not getting fed into the wood. It's just rubbing. Again, rubbing, friction, heat, burning, cause burning. Multiple passes, lingering in the same area. If I set my passes just because I'm worried about my machine, can my machine handle this or can my machine handle that? I want to be fair to my machine and my bits and all that stuff and everything. And I want to take appropriate passes. But if I'm cutting through, let's say 3/8 inch thick material, just as an example, and everything, and I'm using a 1/4 inch end mill, rule of thumb is generally half the diameter of the bit or less on your pass depth, right? Or more, sorry, not less. Well, it could be either or in this case, but if I'm taking, if I should be taking that 3/8 inch cut and at a minimum or a maximum, maximum, don't want to get tongue tied, in 3 passes, maximum 3 passes, 1/8 of an inch per pass, boom, boom, boom. If I'm taking that thing in, let's say I've got it set and I'm taking in 8 passes, just because, right? Because I don't know any better or whatever the case may be. My bit is taking a 32nd of an inch per pass or whatever the equation comes to, whatever the math comes to, but it's lingering so much in that same area. And all it is just building up heat and over and over and over again and everything. And it's it's going to take my runtime and make it last for, longer than it should. But also I'm building up heat on my bit. I'm burning my wood. I'm just being insufficient. So more passes doesn't always mean better. Okay. Whatever your machine's rigidity and strength can handle without flexion, deflection, and all that stuff with the gantry or this or that, or, causing it to lose steps, whatever the case may be, whatever your bit can handle, you should be taking, appropriate passes. Half the diameter of the bit or less. Now, where that comes into play is if I'm running on my little 1824, which is a hobby unit, not built for, big aggressive cuts and everything like that. And I'm using a 1/2 inch cutter, I'm probably not going to take a 1/4 inch pass depth on it because it's just the rigidity. There's a possibility of flex and things like that and everything. So I'll probably minimal 1/8 of an inch per pass. I'm not going to go any less than that. 1/8 of an inch per pass is my minimum for me, my minimum and everything. But I would experiment with 3/16. If a 1/4 was a little much for it or whatever, then 3/16 would be kind of my next, option, or an 1/8 would be that I'm taking an 1/8 of an inch per pass and all. But I'm gonna test my cuts. I'm gonna listen. I'm gonna watch. I'm gonna carve, and I'm gonna see if can it handle that 1/4 of an inch pass? How's the sound? How's the visuals? Do I need to reduce it to an 1/8 of an inch per pass and all that? So I'm probably going to set the tool path up to be half the pass depth will be half the diameter. And then at the machine, my first cuts within the first few seconds, I'll be listening and observing. I'll know if, I need to go back and recalculate that, and adjust it on, and everything and whatever. And in my software, I can come in and I can, if I need to, if let's say that I don't have Vectric software on the computer that runs my machine, I do not want to go in and have to go to Vectric and and change and recalculate and all that, and then come back out to the machine and stuff. If I have to, I have to. But also, I can go in and I can go to Notepad++, which is a text editor. I can open up the toolpath in there. I can do a search and find all of these, and I can either do one of two things. I can slow down the feed rates or the plunge rates. So if I am taking an aggressive pass, it's plunging a little slower, or I can change all my, eighth inch, my quarter-inch pass depths, find all the Z 0.25 and change it to Z 0.125, whatever, right? I can make all those changes on the fly where it changes all those and everything. So I can do a text edit if I have to on the fly, or I can just go back to Vectric, recalculate, change the toolpath, recalculate, resave it, and come back out to the machine. Whatever the situation is for you, whatever you got to do, you got to do. But if I have to slow things down, then I can make adjustments, on the fly or whatever but I'll know the next time I make that cut, I can't do that again, and I'll go and I'll change my tool database for that pine or whatever it was that I was carving to aggressive on. I digress. So anyhow, multiple passes, lingering too much causes, in the same area, causes that heat, that dulling, burning, not necessarily dulling, but burning. Now, let's, before we blame the bit, all right, before we blame the router bit, it's a cheap bit, or this and that and all that stuff. Here's what we want to do. Increase the feed slightly. Go faster, like I was just telling Kevin. Go faster. Reduce the RPM slightly. Slow down the spin of the bit. Listen, all right? See if those adjustments make a difference and everything to you, to your cut quality and all that stuff. And if your controller software doesn't have that ability to do it on the fly, which most of them do, I think a lot of them have what's called an override. There's an override and stuff that you can do, but you want to do that. If we're burning or squealing, which leads to burning, increase the feed rate, slow down the RPMs, listen, make whatever adjustments we need. Okay? Now, golden rule. The golden rule is not like the golden ratio. The golden rule is this: how to adjust. Okay? Change one thing at a time. Change your feed rate. Give it a little bit before you change the RPM, or vice versa. Change the RPM, give it a little bit before you change the feed rate. Don't just go in there and start clicking on the feed rate and the RPM at the same time, because then if you do that, you're not figuring out what the problem is. Was it my RPMs were too fast, or was my feed rate too slow? Which one was it? Because I made both changes to, I can't tell. One thing at a time. Change your RPM or your feed rate. Pick one. I don't care. Go faster. Listen and observe for a little bit in the cut. Then slow down your RPMs. Listen to the cut, Did that feed rate make a change, right? Now, let's say I slowed down my feed rate and it's still kind of squilling and all, so I slow down my RPMs and all of a sudden it gets quieter and things start going good. Well, my question I would ask myself is, was it the combination of the changing the RPM and the feed rate, or can I go back to my normal feed rate, 100% of my G code, slow down my RPM, and the change, does the change happen there, or was it the combination of both? Because if I don't have to slow down my cut, if I don't have to increase my cut, if I don't have to increase my feed rate, my cut, and it was just the RPM that I needed to reduce, wonderful. I want to keep my cut and my cut quality, my time and all that stuff and everything. Just because I'm going faster doesn't mean I'm going to get a better cut. It's going to, that could have an adverse effect. Even though I'm getting good chip load, good sound and all that stuff, in some cases on certain woods and all, it could have an adverse effect and all. I have a feed rate set for a reason, whatever the case may be. So which one of the adjustments made the difference, or was it both? So the golden rule: change one thing at a time and observe. All right. Changing multiple settings, you won't fix the issue, or you won't find out what the issue is to fix it. All right. Now we're going to get into a little bit of material specific guidance. And I've only I've only picked 3 materials for you guys for the lesson, because we're going to try to wrap this up so it's not too late. It's already 10 o'clock and everything, but we're going to be talking about pine, because that's kind of like a, a material that people use. We're going to talk about plywood, layered wood, plywood and everything. We're going to talk about MDF really quickly. And then we're going to talk about like a cherry, a hardwood, cherry, or just, hardwood in general. And then we're going to do a light reference on acrylic. Okay. And then we'll move on from there, and then we'll wrap it up. All right. So let's just talk about this. Here's the material specific guidance. Okay. 1, let's talk about pine really quick. It's a softwood, very, very forgiving. Okay. So we can have incorrect feeds and speeds, and it's probably not going to hold us accountable. It'll probably cut okay, because in most cases the bit will cut through those softwoods like pine and cedar and all, like butter and everything. So it's very forgiving. It's easy to cut cleanly. It's easy to cut clean, a pine and everything, and all, if you have the right settings and all, but it can fuzz if the feed rate is too slow. So those little fuzzies and all, very prone to those little fuzzies and all if you're going too slow. Okay. So here's what you want to watch out for with pine. Fuzzy edges increase your feed rate slightly. Okay. The going too slow, it's not shearing that material, efficiently and all. So fuzzy edges, try increasing your feed rate and see, how that does and everything and all, to reduce that fuzz and that effect and all. Tear out. If you're getting tear out on your pine, this is where you want this are the things that kind of come into play. A dull bit, of course, is going to cause tear out. It's going to be tearing through the wood, then shearing. Okay, so bit sharpness plays a role with tear out. And then proper pass depth. Too many light passes in the area that causes that burring and all that also causes an adverse effect on our edges and everything, tear out. And we're just lingering too long, in the area, and all it's doing is just beating it up, right? And things like that. So tear out in pine, what you're looking for is bit sharpness. Also, try increasing your pass depth and everything. Okay, and that's really it. Pine is forgiving. It cuts cleanly and easily with the right settings and everything. If it is prone to fuzzing if you're going too slow. So if you do get fuzz, go faster, feed rate. Okay. And if you're getting tear out and everything, try increasing your pass depth. Okay. So that's just kind of, again, these are the principles. It's not no math, no charts and all. This is the principles, things to look out for and stuff. Now, the wonderful thing about all this and all is you're going to have a printout that you can print out that provides you with all these principles. Okay. I've done some work for you. All right. Plywood. When it comes to plywood, by the way, ladies and gentlemen, is layered wood, glued. So it's veneers, individual veneers, glued and everything. In most cases, the grain you have, your grain is kind of crossed. Each layer, the grain is alternated and everything to make the plywood more stable and everything like that, which of course we're cutting with the grain, against the grain, with the grain, against the grain. So it could give us adverse results and effects and all that stuff. So just know that the glued layers, each individual glued layer of the plywood, they act much differently than wood, right? Hardwood and everything like that. So plywood is, it is what it is. What we want to watch out for is the clean edges, the chipping and all on the veneers. So down cut bit, if you're just doing pocket cuts and profile cuts and things like that, and you're not really cutting through the material, down cut with down cut spiral, down cut bit with your plywood. If you're cutting through your plywood and you need that mirror finish on both sides, that clean chip-free finish on both sides of the plywood, compression, where it's a combination of the upcut and the down cut in one bit and everything. Now, I'm not getting into a bit discussion tonight. We'll do that in another class and all that stuff, bit fundamentals and all that. But for that clean, both sides of your plywood, compression. But if you're just pocketing or carving and all that, down cut and everything. Now, generally 99.9% of the time, the tear out happens on the top veneer. Okay. When it comes to plywood. So what you want to watch out for is with plywood, you want to use a down cut bit or a compression bit, and you want a lighter kind of finishing pass. Sorry. If I'm doing a profile cut, I'm most likely going to use on the profile toolpath within the Vectric software, they have a function called the last pass option and everything, where if I'm doing multiple passes and everything, it'll carve a certain distance away from the line, whether I'm carving on the inside or the outside of the line, by whatever I specify. Let's say I say a 32nd of an inch. It's going to actually do that profile cut, but a 32nd of an inch away from the line. But when it gets to its last pass, it actually goes up to the line and takes the whole cut, on just that small, remaining 32nd of an inch full plunge, on that last pass. And so if you are doing what's called a finishing pass, on that, try, if you're getting tear out and things like that, try a lighter finishing pass on that step over and all, just go a little lighter instead of, bigger. I wouldn't do a 1/16 of an inch last pass cut, and then on that final cut, it steps over a 1/16 of an inch, and it's taken that 1/16 of an inch with the full cut and everything, because that could cause a lot of the top veneer to chip and everything. So we would try, what we watch for and all is, if we're getting tear out and stuff like that, try lighter finishing passes and all. Now, if we are getting chip out and tear out on plywood and everything, then we also want to keep an eye out for and avoid aggressive single pass, cuts early on. So if I'm, you'll see a lot of people, I can cut 3/4 inch with one pass and all, and on their machines, they might be able to go fast enough and deep enough in the bit where there's very little chatter to where they get nice clean cuts and everything, in their passes and all. There's a great video, it's a short video, but there's a great video on YouTube. The 7 tricks to perfect plywood cuts, I believe, is the name of the video and everything. Very good video to watch when it comes to cutting plywood and everything. But we want to avoid, aggressive, single pass cuts early on. We might, we could break the surface. Okay. When I say early on, is that first pass, right? If I do the full plunge, and everything early on, I'm most likely going to just blow out the plywood and all that. But if I take a breaking pass, if you will, which is basically the first pass that kind of, a decent depth that breaks that top surface and all, then my next passes and everything, I could be, more, I could take more of a cut, and I can adjust in Vectric. It gives us the ability to set the passes, and it also gives us the ability to set the pass depths per pass in the toolpath, and everything. There's a button. It shows you how many passes that you're doing. It says set passes. You can change the passes, and you can change, I want the first pass to be 1/8 of an inch deep, and then every pass after that to be 1/4 or 3/8 or whatever it is, right? So early on, less aggressive first pass, early on pass, and then from there you can be a little bit more aggressive and all to kind of reduce that tear out, because the tear out's going to happen right on that first pass generally. Okay. And that's really all I got on plywood. All right. So MDF let's talk about that for a second. And with MDF, wonderful thing about MDF, it's very consistent. Flat, true in most cases and everything, but the cut is very consistent. And generally it's a pretty good cut. Now, upside, very consistent. Downside, produces fine dust. That's dangerous fine dust and all that wonderful jazz. I'm not going to get into you about safety protocols and all that crap. But well, no, it's not crap. We'll talk about safety PFE later down the road. But it produces a lot of fine dust. So that's kind of the downside of it. But it loves, MDF adores steady, clean cutting. Consistent pass steps, nice feed rates, RPMs and everything. It just takes those cuts so well and creates nice, beautiful, clean results with little burning. If you're getting burning on the tip of your bit, you actually see lines on the edge of the bit for those cutches, and you can actually see those pass steps and everything, on each pass on the MDF on the edge and all, because the bit's kind of getting heated up and stuff like that. But that's where a finishing pass comes into play as well too. That little final pass on the profile cuts and things like that helps. But you can do ramps and stuff like that. But a nice combination of feed and speed, MDF just eats it up, boy. And it's a really nice cut, clean cut and all that. So it loves it. Now here's what you want to watch out for with MDF: burning. MDF it's a compressed paper, if you will. Those chips are ground down to a fine pulp, and turned into this, pressed into this MDF, right? So it burns very easily. So if you're getting burning edges on your MDF and everything, you're going too slow. Try speeding up a little bit, okay? And again, notice I haven't said anything about RPMs. So this is kind of feed rates when it cuts. We're always going to kind of check the feed rate first. Are we going too slow? Are we going too fast? RPMs will be secondary. We'll adjust that, accordingly after. But we're going to always try to slow down or speed up or what have you. If we're getting burning edges, we're going too slow. So we got to go faster. Okay, faster. Now, if dust collection on MDF isn't good, no, we're going to start getting dust building up, and that dust will just pack in. And in some cases, I mean, it can pack in into tight spaces, all like clay almost. Even though it's freshly cut, it still compacts quickly and all. And our bit is doing more work than it should be doing. It's doing twice as much work and all, which builds up heat, and which causes burning, and all that stuff. So good dust collection is very important when it comes to MDF, and it's going to make all the difference in the world in the quality of the finish. So, fun fact, MDF is one of the, believe it or not, it's the cheapest, but it's great for learning. It's great for learning speeds and feeds, combinations and things like that. It's great for learning, about pass steps and plunge rates and everything. It's dense, it's a compact, dense glued material and all. I mean, it's not like hard as, Purple Heart or anything like that, but it's dense. So it's great for, testing your machine, hey, can I do a 1/4 inch pass? Can I do a 3/8 inch pass? Whatever, whatever it is, just testing your machines and everything. And because it's predictable and it's consistent, flat, it's true and everything and all. There's no layers, there's no veneers to like that can make a difference, or there's no different fibers, open grain pores on oak versus a tight grain hard maple or whatever the case may be. It's very consistent, so it's a great material to practice cut on, to just learn your speeds and feeds and things like that, kind of learn how to start. Like if you do have the ability to adjust things on the fly, learning how to properly adjust on the fly, feed rate first, RPM second, but learning how to adjust on the fly, MDF is a great test subject for that, learning how to adjust appropriately and use your software, how to actually use the function in your software and all. So ideal for learning feeds and speeds, and it's predictable. All right, we're almost there. We're getting there, guys. Stick with it. I hope you're liking what you're learning tonight. I hope you're getting something out of it. You're going to get a little printout so you have something to refer back to on as well. The link is going to be in the chat here in just a minute so you can download the PDF and everything and all. Now, cherry wood. Okay, so this is basically, this is going to be our hardwood reference, right? So even though I'm talking about cherry, I'm really referring to hardwood in general, you know, your hard maples, your walnuts, cherry, things like that. All right, so much harder than pine. You know, we know pine is prone to fuzzing and things like that by going too slow and all that stuff. But your hardwoods, like cherry, much harder than pine. So it burns more easily. Okay. Very much prone to burning more easily and everything because heat builds up quicker and all. And it absolutely shows your mistakes clearly. You'll know when you burn your edge of your cherry and all that. You'll see the dark burns and things like that. So all the mistakes, all the feeds and speeds, inaccuracies, and all that stuff in our cuts, hardwoods are going to show it to us. You know, and we either have to clean them up and sand them or, you know, whatever the situation is. But we're going to see it a lot clearer than in most cases. Here's what we watch out for. Okay. Burn marks. Again, if you're burning, go faster. Now, here's where RPMs come into play. Okay. So on hardwood, we really want to, if we're burning, we do want to increase our feed rate, but we can also, it could be, we don't have to always go to the feed rate on hardwoods and all. It could also be the RPMs. So we could try slowing down or increasing the RPMs first before the feed rate on our hardwoods. Okay. Or it could be a combination of the two, or it could be one or the other, but we don't always have to. So our softwoods and, you know, our plywood and our MDF and all that, generally it's the feed rate we want to adjust first. Plywood or RPMs are secondary, but on hardwoods, the script flips. Okay. The script flips. Yeah. So we can try, it doesn't flip permanently, but we can try changing our RPMs before our feed rate, and or, you know, a combination of both. But again, one thing at a time, give it some time, observe, listen before you start adjusting something else. So that way you can figure out what the issue is and fix the issue. But so burn marks, either reduce your RPMs or increase your feed rate. Okay, because burning is typically a derivative of rubbing, and rubbing means I'm going too slow, my bit's spinning too fast. So slow down your RPMs, go faster. Okay. All right. So now clean finishes when it comes to hardwood. So in this case, the things that I said about pine, plywood, and MDF, as far as those multiple passes, you know, causing burning and problems and things like that and everything, you know, more passes, you know, and stuff like that. That's kind of opposite a little bit of hardwoods. Hardwoods, clean finish. If we want a clean finish, typically we want multiple lighter passes to help us with that. That's why I said, it's like, wow, it's like, how do I keep up with all this stuff, right? This is where we test cut on different materials. We make our notes and we go in and we set our, you know, we set our feeds and speeds of what we observed and what we found out, you know, for our, you know, our tools and all. So that way the thing, you know, we have some hard thinking and stuff and observing to do when we're testing. But once we get that tool database set up and all, then it's a matter of just selecting our tools, selecting our material, and just going. We don't have to do all that thinking every single time we make a cut. Just like, you know, learning to ride a bike, there's going to be some falls and trips and all that stuff right at the beginning. Learning your speeds and feeds for this material or that material or this material or that material, you know, learning all that for those first test cuts and kind of getting things honed in, falling and tripping and rolling over the handlebars and busting your lips open and all on that bicycle. Eventually, you're going to be able to just jump on the bike and start riding. And then later down the road, hell, you'll be running on half pikes and ramps and all kinds of stuff at the skate park. You know, it's the same thing with your CNC. You're going to do your trials and tests and all, go the headache of all the math of how do I keep up and remember all this stuff to now that I've actually observed, I got my tool database set up. I just select the tool, calculate the tool path, and I can feel confident in my cut. Right? It's a little bit, it's not going to happen overnight. Now, back to our hardwood, our cherry in this case, but hardwood in general. All right, so cleaner finishes, multiple lighter passes help. Now, with our hardwoods, we get rewarded with patience and sharp bits. Not everything has to be cut in 5 minutes. If the cut takes 20 minutes, 30 minutes, an hour, or whatever, multiple light passes, you know, and everything for those clean finishes and all, we got nice sharp bits helping us and everything, we're going to get rewarded with great finishes, less work we have to do after the math and all that stuff and everything. So the hardwoods and everything, they kind of, it will reward us if we do right by it, you know, and get those clean finishes and all. So if we're burning, go a little faster, slow down the RPMs, one of the two. If we, you know, want clean finishes, try multiple lighter passes. And in the end, our results, it's going to be a little bit longer carve, but it pays dividends in the end where we have less work on the bench. All right. Hopefully this is making sense and all to you. All right. So here's a real quick, let's just quickly light reference on acrylics. Okay. Just for a minute, you know, away from wood for just a second. I don't have to state the obvious, but acrylic is not wood. Okay. So what the key difference is with acrylic, it can melt, not just heat up and cause burn marks. It can melt. And if it melts, it can create a molten ball of lava that one can get flung around, but also it gets stuck on your router bit and you have to sit there and babysit the cut. When I'm cutting Lexan or plexiglass and all, you got to sit right by the CNC and watch and everything. If you don't have the right cut speeds and feeds and everything, and you literally got to stop the cut, turn off the router, pluck off the molten ball off the bit, turn back on the router, unpause. You know, it's a game that you got to play and everything. So it melts instead of burns. And heat, buildup is the enemy. So we want to make sure that we do get our cuts right, our RPMs and our feed rate and all with acrylic, because we're not just with acrylic, we're not just worried about, you know, dulling the router bit, just getting through the cut. You know, heat is going to cause melting. Melting is going to lock up our bit. And yeah, it's just a nightmare. So here's what we watch out for. Okay. Melting. If we're melting, the feed rate is too slow and the RPM is too high. Okay. You're spending too much time in one area and the bit is spinning way too fast. Again, increase the feed rate, slow down the RPMs. All right. That should help reduce the melting of your acrylic. Now, clear chips, acrylic will, with the O-flute bit and things like that and all, or a 2-flute, you know, plastic cutting bit. It doesn't have to always be an O-flute, but clear chips on the acrylic are good. Chips flying are good. Gummy chips are build up, you know, gummy kind of build up where it builds up like a molten on the edge and everything and all is not. Of course, we know it's not good, right? But we want the chips flying and everything. So if we're starting to gum up and everything, we're going way too slow and our bit's spinning way too fast. So make some adjustments. And in this case, just like the hardwood, we can do either or. We can adjust the RPM or the feed rate to get that cut quality that we need. Okay. And we don't want to spend a whole lot of time trying to figure it out on our plastics, because by the time, you know, we get it figured out, if we're cutting through 1/4 inch plastic, the cut's done. And now we have a big bowl. We got a lava wall on the edge of the plywood that we have to break off or whatever and all that stuff. So test cutting is where it helps us out on scrap materials of the same type of material. You know, figure out your cuts and all. So that way, when you're actually cutting the real stuff, when it counts, you've got your settings and all. All right. So, so chips are good. Molten gummy buildup is bad, right? So when acrylic melts, speed up the feed rate, slow down the bit. Okay. Do not slow down your feed rate. Never slow down your feed rate on acrylic if it's melting, because that's just going to make it worse. All right. So that's the materials I want to talk to you about. So here's the deal. I want to end this and kind of start wrapping this up with a little bit of, if this happens, try this. Okay. So problem versus a fine adjustment that we're going to make. Okay. So problem, fine adjustment we're going to make. If this happens, try this. All right. That's the category. So burning is the problem. Increase the feed rate slightly. Okay. So try that. That'll be your first thing. Acrylic, melting, increase the feed rate or reduce the RPMs. Okay. Problem is melting. Or try this. We can do slow down the RPMs and increase feed rate. One of the two. Okay. Chatter, right? So I better shaking. Reduce the pass depth per pass. Give that a try. Okay. Try reducing the pass depth before you mess with the RPMs and the feed rate and all. See if if it's a problem with the bit, your rigidity of your machine, whatever the case may be. But try reducing your pass, your depth per pass first in the case of a chatter. Okay. Fuzzies. Problem is fuzzies. Increase the feed rate slightly. Okay. Rough edges. Try lighter finishing passes. So that finishing pass, whether, that last pass scenario and everything, if we're getting rough edges on that cut, try, don't make the last pass setting too big of a number, make it smaller, 64, 32nd, that kind of thing. Rough edges, try lighter finishing passes in the case of rough edges and all when it comes to your hardwoods and even plywoods too. All right. Now, sound, audible is going to be your best indicator. Your ears, they learn faster than you learning any charts. Okay, speed and feed charts and all that stuff. Your ears are much faster. So a good cut sounds smooth, consistent, calm. The bit's not struggling. It's not, it's not like intense. It's just nice, calm, smooth, consistent sound. Not a squeal. Maybe it's not going to be quiet because it's got to still cut through the wood. It's still taking wood and all, but it's a consistent, smooth, calm cut. All right. So that's a good cut. That's what it sounds like. Bad cut sounds screechy, angry, intermittent. So it's just sounds aggressive, man. It's squealing and screaming at you, and the squeal could be or it's not really going to be a consistent squeal. It's just going to, just depending on what's going on, it's just going to be howling and things like that. So it's bad cut is screechy, angry, and intermittent. That's what we want to avoid. And my final advice to you is you don't need perfect numbers. You just need good habits. Test the materials that you're going to be working with. Take notes of your observations. If your CNC software has the ability to make adjustments on the fly, that's wonderful. If you have a router versus a water-cooled spindle, you change the RPMs on the dial on the router. And you can do that while you're carving as well. And everything. You're not going to be able to change the RPMs in the software if you have a router. If you got a spindle, you're good to go, kind of thing. But you can still make spindle, or RPM adjustments on the router as you're cutting and all, and everything. Just don't go too aggressive. Small little notches on the turns and stuff. But take the time to test when when there's not a big production day. I got, hey, this is a great time for me I could still make something cool while I'm test cutting. It doesn't have to always be just lines or squares or circles or this, that. I can actually make something, but I'm testing the different materials and testing different speeds. I'm pushing my router a little bit, to see what it can and can't do and what it can and can't handle and all that stuff. But I'm taking notes and everything. And I'm going to go back and take the time and set up that tool database, with the different material and whatever speeds and feeds that I landed on and stuff and whatever adjustments I made and everything. And you can do the math. So here's the deal. You're not always running so if I set my feed rate and my plunge rate and my tool path to 50 inches a minute and 10 inches a minute for the plunge, I'm not always going to be carving at that. The G-code's not going to be always hitting 50 and 10, and stuff like that. My feed rate, the 10 most likely I will, but the 50 is going to vary depending on if I'm going into a corner, it's got to slow down to turn the corner, and it accelerates to go out of the corner. If I have nice straightaways, then yeah, I'll get to 0 to 50 inches a minute, no problem. But if it's short turns or short runs, I'm not going to be, always hitting 50 inches a minute. So how do I really gauge how fast I was actually going? Well, that percentage and all, if I can drop down 10% of what my G code is running and stuff, if I set my G code up and my tool path up at 50 inches a minute, and I ended up adjusting, and I adjusted down, let's say 20% of that, and everything. So I was running, 80% of the what the G code was set for. I can do that math. I'll go back in and set that, and all the slowdowns and accelerations adjust with it. If I'm 100 inches per minute and I've reduced 20% down, I'm running 80 inches a minute, and I go back and set my tool for that. All the accelerations and decelerations adjust as well too. And everything. I don't have to know every little number that it hits, just the main number. How fast, how much increase or decrease did I do on what I'm going? And I want to say, I don't know every controller in the world. I know Planet CNC has 10% increments. Other controllers, I'm not sure what you guys and girls may have and all that stuff, but make notes, do your best and everything, and try to build that tool database. Take the time. It's not going to happen overnight. You're not going to get it in a week. It could be months before you get a nice tool database and all that stuff. But if you don't work at it, it's not going to get done. If you don't practice every once in a while, take notes and make adjustments and things and test, you're never going to improve your situation. You're just going to always be doing what you do. Right? So again, you don't need perfect numbers. You just need good habits. All right, everybody. Last two things in the advice and all. Small adjustments. Don't be too aggressive on any adjustments you make on the RPMs of the feed rate. Small adjustments. The 10% is kind of ideal and all that stuff, but sneak up on that perfect, combination or whatever. And then consistent testing. Test whenever you get a chance on scrap woods, whatever. You can still make cool little keychains and all that stuff. I don't care, but just test. Feeds, speeds, learn it. Don't memorize it. Okay? All right. That is it. What I need to do really quickly, give me just 1 second, and I'll give you the link to everything you learned tonight. Let me see here. You guys are Spindle TV exclusive. Spindle TV exclusive. That's you. See here. All right. Share. Everybody with the link can have access. Go into here. Generate the link for your download. In the chat, ladies and gentlemen, right now, click on that link that I just posted there, and it will automatically download a 7-page PDF for you. the principles of speeds and feeds for you to save on your computer, print out, do whatever you got to do. But everything we discussed, just kind of the things, what to try, what not to try, the different, the keys. And again, this is just the principles, how to understand what's happening at the table and everything without all memorizing the numbers and the charts and the this and the that. You set your speed and feed and what you have in your tool database. You listen and you watch the cut and you adjust accordingly. Small adjustments. Note those adjustments that you made and all, record them in your tool database and everything. And over time, it'll all sort itself out and everything. So, all right, gentlemen, did I put y'all to sleep? How are y'all doing? Y'all still with me?
Back and forth.
All right, cool. Well, hopefully you got anything on there. What's that? Also link for OmniControl. You talking about the manual for OmniControl, JR?
Yes.
Yes. I can give that to you. Manual. Pretty straightforward. It's manual.omnicontrol.systems. Here you go in the chat. Paste for anybody that has a digital wood carver. Hold on. Manual.omnicontrol.systems. Copy and paste that and everything. Also on the digitalwoodcarver.com website under support, it says user owner manual, right? So that'll link you to it too.
Come through, Laney.
What's that?
It's a.
It's not clickable. Hold on a second. Let me make it clickable. https://manual.omnicontrol.systems. There you go.
Thanks, sir.
All right. Well, listen, ladies and gentlemen, we had a 2 hour and 36-minute course. And typically what I'm going to try to shoot for on these classes, in most cases and all, on things like this where there's some learning and all, they might run a little long, but I'm going to try to shoot for 1.5 hour classes. And the goal, that's what the goal is going to be. There's going to be times that we do go over and all, but that's going to be the ultimate goal when we're doing design work and stuff like that on this shared learning and everything. Yes, Mark, your video is finished rendering this morning, and it'll be in your inbox tonight. But for the most part, we're going to try, 1.5 hours to try to, time it that. So that way it's easy to digest and absorb. We're going to, when you get access to the website, that's when it's really going to benefit you to the most. For like, if there's anything you miss, you'll be able to go back and watch videos again. Of course, you can do it on the YouTube channel too, but you'll be able to see the calendar of what's coming up and what the classes are. And then you'll have access to all the PDFs and documents and everything for downloads in the library and everything for the learning resources and stuff and the projects and all that I'm putting together for you. And everything. So I will make a big announcement as soon as all that comes out. And in the meantime, I'll just, I'll make posts for you to let you know what's coming up next week, and also you can kind of plan for it and all that. Now, what we're going to do is we will just kind of the first back of the New Year's and all. We will have a class this coming Thursday, but after this coming Thursday, the classes will be every other Thursday from that point, and everything. So we'll have a class this coming Thursday at 8 o'clock, and then it's going to be alternating for the live events. But then the off Thursdays of the live events, you'll have videos released of project videos and stuff and everything that you'll be able to watch, and that'll be just exclusive for you. That you'll be able to watch and download the files and all that stuff you'll have in the description and the links and everything. So 1 week basically will be a recorded, edited video, and then 1 week will be a live. And then it'll alternate every other week like that. And then spread out through that month or whatever. I don't know the exact dates yet, but we'll have what's called office hour Q&As. So those will be there'll be a live event. It might not be at 8 o'clock at night. You know, it's office hours, so 9 to 5 between there and all. But it'll be a live event where you can pop in and ask questions and get answers and all that stuff. And we'll do that every once in a while as well too. Okay. All right. Good stuff. All right. Well, hopefully everybody got that link. If not, I will post that link. Let me copy that link right now again. Let me see here. I will post it in a the feed, the community feed for private members. And I will post it in the Facebook exclusive group just in case you didn't get it here as well. So right now in the Spindle TV exclusive group, that link is there. And speeds and feeds principles. And then I'll post it in the chat or the community after the fact. All right, everybody. Can I have something hanging on those? Oh, I forgot to shave right there. I missed it. Damn, man, I'm no good at shaving. Okay, gentlemen, I'm going to go eat dinner. Y'all have a wonderful night. I thank each and every one of you. And again, Kevin, online, you type in speeds and feeds on a Google search, or you type in chip load, all the charts for the different, and you can even be specific, mana tool speeds and feeds, or speed tool speeds and feeds, and those charts will come up. And in those databases and all that stuff. And there's all kinds of downloads and everything for you. All right, gentlemen, I appreciate you. We'll see you next week at 8 o'clock, next Thursday at 8. And then we'll start our bi-weekly lives and then our bi-weekly recorded classes. See you, everybody.
See ya.